Please about the things. Only six people joined, right? Thank you. Coming on. Hey, dude, am I audible? Yeah. uh, Could you please unmute yourself? Please, whether you are able to hear me or not.
Yes, sir, you're audible.
Okay, so there are only seven students right now. So any more people is about to join? You know? Please switch on your video first, and after once we will done with the interaction session, so that we will start the class right now. Okay. So could you please switch on your video? Anirudh, Ritik, one Riddhi, Nandini, and Divyasa. So it's easy for me to interact with you people right now. After that, once we will done with the interaction, then we'll come to the right. Next, Anirudh and Riddhi, Nandini, Divyasa. So Riddhi, Nandini, and Divyasa. Can you hear me? No. So how these guys will? Okay, so okay. No issue, no issue. So first of all, I'm introducing myself. I'm Ankit, and I did my graduation from Birla Institute of Technology, Misra, and I did as a senior engineer. I worked for 2 years as a senior engineer in Vedanta Aluminum Power Limited, right? And after that, I cracked the gate. I did my master's from IIT Roorkee, and from there, uh, right now I am working with the Indian Institute of Science, Bangalore, right? I mean, you people know about this institute, right? So basically, we are here to talk about the GATE examination, right? So today I'll be starting with the chemical reaction engineering. So first, I want you people to introduce first, and after that, uh, first, Pranati, you start first, and after that we'll go subsequently.
Sir, am I audible?
Now you are audible, yeah.
I'm Pranati from JNTU Hyderabad, sir. I've completed BTech third year in chemical engineering. Right now, I'm pursuing fourth year in
Next, Ritik.
Hello, am I audible, sir?
Yeah, you are audible.
Sir, myself Ritik, and I'm from Chennai and studied fourth year in SSN College of Engineering, Chennai. Completed fourth year, and I'm pursuing GATE. Thank you, sir.
And Anirudh.
Sir, am I audible, sir?
You are audible. Go ahead.
Good evening, sir. My name is Anuj Singh, and I am from Gazipur, Uttar Pradesh, and I have done my schooling from my village itself, and currently I am pursuing my BTech in chemical engineering from NIT Raipur, and I am in third year. That's all. Thank you, sir.
Divyasa.
Good evening, sir. Myself, Divyasha Sahu. I am from Bhubaneswar, Odisha, and I am pursuing my chemical engineering degree in NIT Raipur, and I have completed my second year, moving to third year.
Next, Riddhi. Riddhi is, I think, busy in traveling, so we can leave. Nandini next.
Good evening, sir. Am I audible?
Yeah, you are audible.
Yes. I am Nandini. I am second year chemical technology. I study in SBTU Kanpur.
You come into the very good. So I think we have done with the interaction. There are only 5 to 6 students are here today. So yeah. So already I told you that I'll be starting with chemical reaction engineering. So first, I'm giving you the broader perspective that you people, most of the people are moving from second year to third year, or some of them you are in third year or fourth year, right? So basically, what GATE examination is, right? That's very important because how much topics you are studying or getting. If you want to switch off your video, you can switch off because it will take lots of data, right? So, so the thing is that in a broader perspective, when we talk about the GATE examination, it's all about only consistency, right? So if you have started any topic today right now, and when you are going, when you are reaching to the close to the examination, right, you don't have to give up. And the thing is that most importantly, when you are studying the topics from the starting, you just try to avoid the silly mistakes. Whatever the knowledge you have, if you are doing silly mistake repeatedly in the GATE examination, it will cost you very much. So, I mean, silly mistakes can pull you out from the top 100 range. So, if you are thinking only to get into the top 100 range, then you have to minimize your silly mistakes at any cost, right? So, from first day onwards, I'll ask you to avoid the silly mistake. What the silly mistakes is. So, let me tell you something about the silly mistake because I'll be teaching you the topics, but first of all, I want to let you what the silly mistakes is. That's very important. Yeah. So can you see my screen, right?
Yes, sir.
Yes, sir.
Okay. One thing is just like you are solving problem. I'm just giving some brief discussion about the silly mistakes. After that, we'll come to the topic. But from today onwards, when I will be teaching you, please first focus on the silly mistakes. Then you will be able to come under 100 range. Otherwise, it will be very tough. How much knowledge you are having, how much concept you covered, it will be very tough to enter into this, right? It's very important, right? And meanwhile, if you face any doubt, you just ask me without any hesitation, right? See, one thing is that just like you are solving the problem, just like you are multiplying 98 into 15, right? Simple basic things I'm letting you to know. So if you are multiplying 98 into 15, but during the examination, the GATE examination, the pressure will be very high. I mean, lots of things will be going in your background, in your mind. And whenever you will be, seeing in the classroom here and there, so you'll get distracted there. So you don't have to get distracted there. So to avoid that distraction, because that distraction will cause you also a huge loss. So just like you are multiplying these things, most of the time multiplication, you will do wrong multiplication. Even if you are having GATE calculator, virtual calculator will be there, but you will do wrong multiplication, sometimes wrong division, sometimes wrong addition. So from today onwards, whenever you are solving any question, try to solve up to the last. If you are solving previous year GATE questions, then try to focus that if whether I am getting 0.379 to answer or not. You don't have to give up to 0.372 because sometimes GATE will ask you to write a digit up to 379. I mean 3 digit or 4 digits sometimes. Sometimes they will let you 101.325. These kind of answer you will require to fill in NAT, right? So you'll have to avoid all these mistakes, right? It's very important. So from first day onwards, you'll have to focus on this. Otherwise, how much knowledge you are having, how much questions you are solving, it will cost you. And let me tell you one more thing. It's very important. If you are solving 55 question in GATE, but out of 55 question, if you have solved, and if someone is solving 48 question, but you have done some good silly mistakes, but this guy have done very less silly mistake. If out of 43, if this guy is his question is I mean he's making correct 44 question, and if you are making correct like 46 question, then your rank will be behind this guy, right? Even if he has solved only 48 question and you have solved 55 question, I'm telling you, you can make 10 wrong question in the examination. It's very easy. Why that 10 wrong question? You are knowing the concept of all these questions, you know, that 55 questions, but due to calculation mistakes, you will do 10 wrong. And if this guy is doing only 4 wrong, the rank of this guy will be higher compared to you, who is solving 55 questions. It's very important that you focus on the silly mistakes. Whenever we are solving a problem during the class, I will be letting you uh, which types of silly mistakes you should avoid. Next thing is that, just like simple thing, whenever any question comes, you try to study the whole line of the question, right? What they are asking. Every sentence is very important because see one thing, next year, 2024 GATE, IISc Bangalore will be setting up a question. The finals, most of the question will be coming from the professor of IISc Bangalore. I'm not discouraging you, but these professors are very smart. These professors will give you very basic questions, very basic. I'm telling you, they will give you very basic questions. But where you people will get trapped in silly mistakes. I'm telling you, if he will give you the question from rate law, if you have not studied the whole sentence of the problem, you will do mistakes. That mistakes you need to avoid. It's very important. Are you getting me or not? No. No.
Yes, sir.
Please reply. I mean, you don't have to worry about anything, right? So if I am asking, because the communication should be from both of the way. If I'm asking, please reply, then it will be very easy for me to communicate with you. Otherwise, it will be tough for me, right? So please respond whenever I ask the thing, right? So up to this, what I have explained you, have you people got it, get it or not?
Yes, sir, got it.
Yes, sir.
Any doubt up to this?
No, sir.
What you need to minimize first, and what is the basic things that you need to do from today onwards?
Avoid
Yes, sir, got it.
If you are writing the GATE, definitely you would be thinking to get PSU and some good college for the masters, right?
Yes, sir.
So for that, you have to get below under 100 rank. If you are getting this under 100 rank, it's very good for you. You will get placed in some good PSU, some good IITs, IISc, right? All these institutions, you will get good master's degree, and again, you will get good placement. If you are not getting PSU, then you are having another option, IIT and IISc. If you do a master's, you will get good placement. So these are the scenario that I am telling you right now. But to get all these things, first and foremost is to minimize mistakes. Because you must be knowing the whole concept, right? But what you will be doing is silly mistakes. We'll solve the problem of the GATE previous year and we'll let you know, right? So think about this, and we'll be giving you some problem that will minimize your silly mistakes, right? So don't bother about this thing. So we'll be starting today's CRE. How many people have studied CRE earlier in the college? How many of you? I won't be asking any questions, so don't worry about that, right? This time,
I have studied.
Yes, in our second year it was there.
okay, so basic things you people have got it, right?
Yes.
Okay. So see one thing, CRE is chemical reaction engineering, right? And this is one of the major topics of the GATE examination. Every year you will get a question from 12 to 15 marks. If you do at least 10 marks from here, because 2 to 3 questions used to be very hard, right? So it will be very tough, but if you will focus on the concept very well, then definitely you'll get 12 to 15 marks very easily, right? And here you will get very less calculation. So the chance of making silly mistakes will be very less in next CRE. This is the very important thing that you should note here over here. So why we study chemical reaction engineering? The thing is that because here you will see this is chemical reaction, right? So if a reactant A is getting converted into product, right? Having rate constant K1 and order of the reaction is 1. I will discuss all of the thing over here, right? So there is a chemical reaction engineering. The first term is chemicals. What is this chemical? This chemical is A, B. All these substances are called the chemicals, right? That will take parts in the reaction. That's why the name is chemical reaction. And why this is engineering that we are studying? Anyone can answer? Anyone has idea about this? Are you getting me or not?
Sir, can you repeat?
So here we are going to study about the chemical reaction engineering, right? So what is chemical? Chemical is like if a reactant A is getting converted into product. So substance A and substance B will be called as the chemical, right? In which A will be called as the reactant, B will be called as the product. And due to which reactant A is getting converted into product, this will be called as the reaction, right? But we know this chemical and yes, but what is engineering over here? And why we are studying as a chemical engineer, we used to study chemical reaction engineering because this chemical reactions if is getting converted into B. These people, chemistry people know these things, no? Right? Why we study engineering? Okay, we as an engineer we study chemical reaction engineering, and this is our core topic, right? No?
Yes, sir. In this, we can say that we can manipulate the process through this reaction so that we get the desired product and optimize the whole process so that we can get our desired product in a cost-effective manner or time-efficient manner. We can say.
Good answer. Anyone else? Do you want to answer?
Sir, how this it will focus on the part where how these reactions can affect the industrial process or like the catalyst used and all different things added or the amount of reactant taken into consideration, how all this affect in the industry. So that is how.
Good. So see, so we know the reactant A is getting converted into product, right? Here the rate constant is K and order I'm writing N, right? So definitely the reactant will be getting converted into product. But our product is B. So most of the time as an engineer, we want to optimize our product, right? Definitely, because we are here to make our good cost for the company, right? So if the company will be benefited, then you people will be getting more and more payment. So at any cost, we will be maximizing this B. So how will we maximizing this B? Chemistry people can know, yes, there is a reaction that will get, a reactant A will get converted to product and having the rate constant will be K1 and order of the reaction will be N. But how we can maximize this B, that chemistry people does not know, right? So we are having some sets of the equipment, right, that we make. We used to call it as a reactor, right? And all these reactions will be happening inside the reactor. So we can design this reactor. we engineer can design this reactor, right? That's why we study this reaction engineering. And this reactor is very important part of any industry, any production units, right? If either you are going in the oil and gas industry, or you are going in the polymer industry, or you are going in manufacturing of any metals, here reactor won't be there, but some different units will be there, right? But I will be talking about mostly oil and gas industry. So to fabricate the design of the reactor, we used to study the chemical reaction unit, where this reactor requires some basic knowledge of the chemical reactions that we people also know, and we people know the basics engineering and mathematics of this reactor. Mathematics. That mathematics we can use to design this particular reactor. And what mathematics we are talking about here is like differential equation, right? Most of the time we used to study differential equation, matrices, and the partial differential equation, right? So we can incorporate all these mathematical concepts while designing the reactor, and we can optimize the product, right? And we can, whenever we need some, enhancement in the rate of the reaction, right, A to B, then we can also enhance the rate of reaction if the reaction is exothermic, if the reaction is endothermic. I'll be discussing all these stuff. So all these concepts we know, we can incorporate all these mathematical equations, differential equations into the design of the reactor. That's why we study the chemical reaction engineering. But that mathematical aspects of the reactor design that chemistry people does not know, right? So that's why we study the chemical reaction, right? Do you have any doubt now? Why we study chemical reaction engineering as a chemical engineer? Anyone has any doubt?
No, sir.
Because see, one thing is that whenever you will be going to the PSU interview, especially I'm talking about the BARC interview, right? Because in a BARC interview, they will be asking all these questions. As a chemical engineer, you are a chemical engineer. Why you study chemical reaction engineering, and how you are different from the chemistry, right? Because chemistry people also know that that chemical reaction and all, but how you are most suitable for the BARC as a scientist, but not as a chemistry people. So you have to defend your answer in this way, that because we know the mathematics, we know the modeling design of these particular reactors while using differential equation, matrices, partial differential equations. So we can design a reactor which is best suited for this particular reaction, which is where A is getting converted to the product having order n is equals to 1 or rate constant is k, right? So you have to give the answer in this way. Otherwise, it will be very tough there to define your answer, right? So all these basic things will make you to prepare for the interview also. So don't bother about that. Once we'll crack the gate and we'll prepare for the interview. No. So think in this way, right? So I'm discussing about here is a reaction. Reaction A is getting converted into product, right? So here already I have told you there is a rate constant and there is the order of the reaction. Here it is called as the reactant, B is called as the product. Okay. So this is a reaction. So you have two kinds of reactions. One will be elementary reaction. Next will be non-elementary reaction. Because whenever we are going to design the reactor, these particular things come into the existence. Very important, right? I'll let you know about the elementary reaction and non-elementary reaction, right? Now, see one thing, as a chemical engineer, what you need to do? First, you will incorporate a reactant. Here, reactant will come in a unit. See one thing, if our reactant is A, it won't be completely 100% pure. There will be some impurities and all. This kind of thing will be there, right? So you need to purify this reactant first. If you want to make a good product, then first this reactant should be pure. So first you will have to send into the purification unit. Okay. After the purification unit, once you will get a pure product, pure reactant A, you will send it into the reactor. Okay. Again, in the reactor, what will happen? Reactant A will getting converted into product, right? Here you'll have to use separator. Right? From separator, what will happen? A and B will get separated. Or if any another impurities are there, you can separate from the separator because it will do a physical separation. So here you will get a product B, right? And if there is any, because 100% conversion is not possible every time. So some remaining A will be here, right? Here A plus B will be here. So again, that A you need to recycle, right? This A should be recycled, right? R. Are you getting or not?
Yes, sir.
No. Everything is clear. Yes. You know, everything is clear now.
Yes, sir.
Yes, sir.
So, have you got some idea about why we are doing all these basic stuff about that separator, that reactor, that purification unit, and all, right? Hmm. Once we have done with all these units, then what we need to understand that types of reaction that I have told you that first is elementary reaction. So, what do you mean by elementary reaction? The thing is, so just like that on the same, if a reactant A is getting converted into product, right? Having order N and having rate constant K. So, see, one thing why I'm writing all these things, you should follow this SOP, right? Because whenever you are writing a reaction, definitely there should be a reactant, there should be a product. Definitely you try to write N and K. N is order of the reaction, K is the rate constant, right? So it is a SOP of writing an elementary, I mean any type of reaction. How will we call it as an elementary reaction if it is happening in a single step? Then this will be called as the elementary reaction. What do you mean by single step? Single step suggests you A is not going to form A star in the transition complex. All these kind of formations will not be there, right? A star or A1 star or A2 star. There won't be any this kind of formation of transition complex, right? Directly A will be converted into product B, right? In a single step only. There is no any extra step will be required in this particular reaction, right? That's why it is called as the elementary reaction, right? It will be occurring in a single step, right? Now, when the reaction is elementary reaction, it will follow power law kinetics. What is power law kinetics? Power law kinetics is minus RA, that is equals to K CA whole to the power n. Right? This is called as the power law kinetics. Right? Now, if a reaction is elementary, I told you that reaction A is getting converted into product B is elementary reaction. So what will happen? Minus of RA, that is equals to K, if rate of reaction is K into CA whole to the power 1. If it is elementary reaction. Why I am writing 1? Just try to understand. For the elementary reaction, whenever the reaction is elementary, that N should be the stoichiometric coefficient of the reactant A, right? So what is the stoichiometric coefficient of reactant A? Here it is only 1. That's why I am placing 1 over here, right? Just try to understand. If I am writing 2A is getting converted, if it is A, if it is B, and I wrote here that it is an elementary reaction. It is an elementary reaction, right? So if I want to write minus of RA, rate of reactions of A, here it is R is a rate of reaction. So what can I write? K Ca whole square. The stoichiometric coefficient should come in the power of the reactant concentration. Are you getting it or not? If I write 2A
Yes, sir.
plus B is getting converted into 3C plus D. And if I write this is the elementary reaction. So if I want to write minus of RA, what will I write? If rate constant is K, so K Ca whole square into Cb whole to the power 1. Right? If I want to write Ma plus Mb is getting converted to K and it is product. So here, what can I write minus of Ra? That is equals to K Ca whole to the power n and Cb whole to the power m. Everything is clear for this now? Nothing. It's clear now.
Yes, sir, it's clear.
No. As I have discussed about the reaction, A is getting converted to B and N and K. So if I told you that it is elementary reaction, I told you that minus of Ra is equals to K Ca. Here the stoichiometric coefficient is 1. That's why I'll have to place 1 over here. So K is called as the rate constant. You all know. And this is function of temperature. Rate constant is a function of temperature, and I'll let you know about the dependency of rate constant on the temperature. Ca, that is reactant concentration. Right? And minus of R, that is the rate of reaction with respect to A. Right? See, one more thing. If I am writing A plus 2B is getting converted into 3C plus 40, right? If this is a reaction, we are given. See, one thing is that why I am teaching you all these stuff. You all people know all these things, but I am clear if IIC Bangalore will put a question on this particular topic, and if the question is MSQ, the question will be very tough. The question will be very tough because they will put 4 options: option 1, option 2, option 3, and option 4. And it will be in MSQ. And they will frame the sentence in such a way that this sentence will be very similar to all of it other. So here the people will do mistakes. I'll let you know how you people do the mistakes while using this elementary kinetics and non-elementary kinetics, power law model, all these stuff. That's why I'm letting you to understand all these stuff. It's very easy, but you should focus on this. So if I talk about A, rate of reaction in terms of A, so I can write minus of Ra, that is equals to K if it is elementary. in Cv whole square, right? Now I want to write the rate of disappearance of A, right? So that is equals to, whether you can write dNA by dt, right? Or you can write dCA by dt. Anyway, let you know where dNA by dt will come and where dCA by dt will come, right? Now, if I want to write rate of disappearance of B, so that is equals to minus 1 by 2 d B by dt, right? Here this will be minus. Right? If I want to write the rate of appearance of C, so what will be equals to 1 by 3 dNC by dt. And if I want to write the rate of appearance of D, that will be equals to 1 by 4 dN D by dt. So we have got 4 equations. Now, what do you mean by rate of reaction? Anyone can define rate of reaction? To define, don't bother about mistakes. I'll let you correct over here. Don't worry. Because see, one thing is that you need to clear all the basic stuff, because IIT Bangalore is not going to ask you all the toughest question of the chemical reaction. I am telling you one thing. IIT Bangalore will be asking the basic things and they will trap you in basics only. That's it. So define anyone rate of reaction.
It is rate of disappearance of reactants or rate of appearance of products.
Rate of disappearance of reactant or rate of appearance of product, right? See one thing. Good. So if I want to write rate of reaction, right? If the reaction A is getting converted to product simply, so I can write rate of reaction equals to dNA by dt simply, right? Or dCA by dt generally. dNA by dt or dCA by dt. What is dNA by dt? If I talk about minus, all right, dNA by dt is there will be Na final minus Na initial and divided by delta T. Are you getting? Since there will be a reaction that will be occurring in a vessel. Right now, I am telling you it's a batch reactor. Those who do not know about the batch reactor, don't bother about this thing. I'll let you know later. Just try to understand this is just a vessel. And just like in your home, you cook any food like that, in a vessel, it's a vessel. Here, A is there. Initial number of moles of A is Na naught. Right? Now, A is getting converted into product B, having rate constant K, and order of the reaction is, I'm just assuming order of the reaction is 1 elementary reaction. So what will happen? In this vessel, A will get converted into B. So after some time, what will happen? The number of moles of A will decrease and it will reach to Na, right? So number of moles of A is decreasing. So with time, so in time delta T, what will happen? Number of moles of A is changing from Na to Na. So initially it will be Na naught and finally it will be Na. Initially time T is equals to T naught, time T is equals to T final, right? So what do you mean by rate of reaction? Minus of Ra, that is equals to dNA divided by dt. So that is equals to Na minus Na naught divided by Tf minus T naught. And you'll have to put the negative sign over here. Right. Why negative sign? Because the number of moles of A is decreasing and number of decreasing with time. So to make this particular things mathematical equation positive, that's why we have to place minus sign in front of this. That's why there is rate of reaction is negative. Right. So here you can write delta of Na by delta of T. Okay. So what I am discussing, this is the rate of reaction. There are two kind of rate of reaction. One is average rate of reaction. And next one is instantaneous. Can anyone define this average rate of reaction and instantaneous rate of reaction?
So it is the rate of the average rate of reaction rate over a period of a long period. Wherein,
See, I'm not getting your voice clearly, so please be loud.
sir, am I audible?
Yeah, you are audible.
Yeah, average rate of reaction is like whenever you take a long period of time and consider the rate average of that, like delta Na by Nt gives you the average rate of reaction, whereas instantaneous rate gives you the rate at a small period of time, an infinitesimally small period of time, that is dNA by dt. When you
Okay.
differentiate that, you
Okay, good. So, good, Nidhi. You know this.